Okay, so then now we are going to make a function for OLS. Okay, then where is our OLS simulation code? Yes, it's here. Okay, it's here. So then let me change its name. I would say rename here. Okay, main underbar OLS. Oh, sorry. Rename OLS. Yeah. And then let me copy it and paste it here. Okay, so then, and we don't need this script anymore. Yeah. Okay, then okay. All right, so then let's take a look at the code again. Okay, the first step is data generating process. We specify the true values, right, and sample size, and we generate independent variables. Independent variables are literally independently generated of the dependent variables. So this is purely exogenous. We have no idea how these independent variables are determined. They are just simply just given, okay, exogenously generated randomly, right? And given these exogenous independent variables and then true values for the model parameters, then we can generate dependent variables. And this is dependent on the exogenous variables and true parameters, right? And this exogenous shocks or the errors, model errors. Yeah. Now the second step is estimation. This is done by human being, right? So that means all the information we have are only the data. The data are x and y and nothing else. We have no ideas about the true values, right? So given the data, we can estimate the parameters for beta, and then using the beta hat, then we can estimate the sigma square hat, and then we proceed to estimate or compute the t values here. Then in addition, we computed r square, and then you must have done with computing the adjusted r square. Right, okay. And then we started with 2 or 3 exogenous variables and tried four independent variables, right, in your homework. And then you could see that whenever you increase the number of the independent variables, then you will have to change the true parameters and the exogenous variables, and then almost nothing else except the number of the regressors, right? So that means as long as the data are given, x and y are given, then this step is simply it has nothing to do with the number of regressors. Once the x and y are given, these parts are just copy and paste every time, regardless the number of the independent variables, right? That means this is very suitable or appropriate for making a function, right? So then we are going to make a function, OLS function, in which the inputs are what? Inputs must be what? Must be the data, x and y. What would be the output? Outputs must be what? Beta hat, sigma square hat. Of course, you can specify the residuals as output as well, and t values r square and adjust r square, so like this, right? So then let's make a function now. Okay. So as always, whenever you would like to make a function, we have to what? Open a new script, right? And we have to declare this is a function file. So type function output, okay, there must be output equals the function name, or say OLS, and input, what inputs y and x and okay, right. Then let me move here. Okay, so then let me cut, or if you are not that confident, just make copy. Okay, I'm going to cut this part. I'm going to cut and paste here. Okay, so then again, so this is a function, so then these commands will be executed given y and x. Okay, so then let's see if these lines can be executed given y and x. Okay, right, so the y and x are here, and then we can compute beta hat using x and y. Yeah, no problem. Given beta hat, can you compute e hat? Yes, we have y, x, and beta hat. What about sigma 2 square? Or sigma hat square? E hat? Yes, we have e hat, capital T. Do we have capital T? It's not here. Of course, that's in this main file, but within function we have not specified capital T yet, right? So then this capital T doesn't exist at this point. So then we have to define capital T within function first. So then capital T is sample size, right? Sample size. How could you see the sample size? It must be what? It must be the number of rows, of x or y, whatever, right? So then I would say rows of x. Then this is sample size, right? Okay, so then now we kept it done. What about 4? 4 is fixed? It's not necessarily fixed, right? Given x, the number of independent variables is not always 4. It could be 2, 3, even bigger than 5, right? We have no idea. And then how could you see the number of independent variables? Where is the information about the number of independent variables? Right? Yes, it must be what? It's what? The number of columns of x, right? So then say k equals what? Cos x semicolon. So this is what? The number of regressors. Okay, so then 4 should be replaced by k, so that this function is generic. Okay, so this function can be used. Okay, this function can be used for any cases with different number of regressors, right? Okay, let me save this file first. Okay, as always, just save it. Okay, then we have one more function file here. Right, sigma square hat, beta hat, right? T values, beta hat, standard errors. All these values can be computed. Yes, R, Y bar. Yes, we can compute Y by using Y. We can compute TSS, RSS, R square, and we report the output here and nothing else. So then the final job is what would be the outputs? What variables would you like to put the output. Of course, beta hat, and then I'd like to return sigma square hat, and then t values, and r square. So you can add outputs as many as you want. Okay, then it's pretty much done. Yeah, it's done. I think so. Yeah. Let's try this function. Right. Then let me make copy and paste it here and semicolon. These are not needed. Okay, so then let me run it. Yes, it runs very well. And what are the true values? True values 1, 0, 4, minus 2. 1, 0, 4, minus 2. Yeah, the estimates are very close to the true values, which means it means two things. First, the techniques, the OLS is reliable. Okay, so theoretically OLS is good, but we have just tested whether this OLS can be applied to real data analysis. Yeah, using this sort of the simulation, right? So then it means the OLS is reliable. Okay. The second thing is what? This code is correct. Right? So OLS is a very good technique. And then this code has no errors, right? So that means what? Now, once we are confirmed with this, once we are confident with this code, then in the next we are going to remove this data generating process, and then what? We are going to load the real data. Okay, and then we are going to do this later. Okay, so for now we are going to improve our OLS function further. Okay, so let me run this again. Okay, it runs very well. Then, but still we need to test whether it runs for any cases with different number of regressors. Then let me try the 3 regressors. How? Then let me try this like this. Just X here, Y is here. Then okay, so then how can I do this? Okay, so then now we have 3 betas and 3 independent variables. Okay, yeah, just delete from, just remove x4 from x. So then x is now 3 regressors and true beta is now 3 by 1, right? So then let me run it. Yeah, it runs very well. Yeah, it runs very well. Yeah, it's okay. So then let me try 2 regressors, beta 1 and beta 2. Then x has only x1 and x2. Yeah, it runs well as well. Yes, that's right. So then yes, so this is the this is how to make OLS function.